The immune system is the defense, so it's the army that God put into our body to protect us from things that are trying to hurt us. Right? So think army. Now, my degree is in cell biology. So when I was at the University of Florida and I was actually studying immunology, I studied with a bunch of guys, and the guys made everything into tanks and archers and ninjas, and the whole thing turned into army things. You know what I'm saying? And I'm being a girl, I would have never come up with that stuff, but it made it so I could understand it. Because I could really kind of see, like the viruses were the Nazis. Because what viruses do is come in and they take over your cell. Now listen to this. Viruses come in, they take over your cell, they take over the DNA, they tell the cell, now you're going to make a whole bunch of little me's. And once the cell has made all the little viruses that it can, then the virus kills the cell and goes and does another one. We're going to kind of do like the guys did in my class because it makes it a little easier to understand. There's two basic types of immunity our bodies have. The first kind is non-specific. There's non-specific immunity, and the actual, I can spell, the actual, God bless you, technical term for it, you do not have to write down, but for those of you that might want to know it, it's innate. Innate immunity. The other type of immunity is specific, and it is called acquired immunity. Acquired immunity has to be produced, whereas innate immunity, it's nonspecific. It works on everything. We just talked about the first largest organ of your body, first line of defense. What is it? Skin. So your skin is nonspecific. The idea is it keeps all the bad guys out. That's the idea. Let's say I ate something that doesn't belong in my body. Whatever I ate had some bacteria on it or whatever. I had chicken salad that sat out on the picnic bench too long, and some bacteria that were in there started to multiply because it was warm, and there was eggs and mayonnaise in there. And when I ate it, I got it, I let it in my body because I just put it in my mouth and swallowed it. Where's the next place that maybe things would get stopped? In the stomach. Very good. The stomach has acid in it, doesn't it? It's kind of like the enemy dropping in and getting dropped into boiling oil or something, right? Because it's this acid cauldron. So hopefully that might stop them. What about, well, can't you just visualize it? What about your eyes? Things can get right into your eyes. So what did God do to protect our eyes? Very good. Our eyes have tears. There's also, remember, our eyebrows and our eyelashes are actually to keep junk out of our eyes. That's the idea. I bet you guys have had something get caught in your eyelash before, and then you went, oh, there's something in my eyelash. Thank God I caught it before it went in my eye, right? So that's their job, is to keep stuff out of our eyes. Our tears have enzymes in them, and the enzymes, they're actually called lysozymes. L-Y-S means to cut. So tears have lysozymes, and what happens is that anything that comes into your eyes, the tears are strong. They cut them up. That's good, right? Now, Juliana asked if the pain and emotion sensors are connected. What it gets down to is, believe it or not, our tears also have chemicals in them that make you feel better. Is that amazing? That God took care of that? That emotionally, when we cry, girls, we all know we feel better after we cry. Guys won't let themselves, so they have to suffer, okay? But if they were smart, they'd do it sometime, right? Because Jesus wept, and he was a guy. He was the perfect guy. So anyway,
that was because he was sad.
It was. So if you're sad, you're allowed to cry. That's what I'm saying. Don't go by what the world says. Real men are allowed to cry, because real men should be like Jesus, right? Okay? And when you're sad and you cry, the tears actually have chemicals in them that help you to feel better, which I don't know about you, but when I read that, I'm thinking, how can people believe in evolution when they study all this stuff? You know, when you read this stuff and you go, really? And that just happened, right? Evolution said you better feel better. I don't think so. But anyway, just let me go. So this is your first line of defense. Now, guys, there's other places that things can come into our body. If you get a cut, obviously, that's not a good thing. And the places that are what we call orifices, where like things can come out of our body, so actually things can actually go into our body in those places, maybe your nostril or something like that. God's also put things to protect us. Who can tell me how does, we talked about this a little bit last week, but how is our lungs protected from things coming in our nose? Yes? There's mucous membranes. There's the cilia that's pushing the stuff back out. There's hairs in our nose. There's all sorts of things in place. And in other orifices that aren't so exposed, that things are coming out of our body, like excrement and stuff, they'll usually have some level of acid to them so that it'll burn off anything that might be trying to come in. That's your first layer of defense. The skin, the tears, and your stomach acid. If something manages to get in, there's some more non-specific response that's pretty cool. The next non-specific response, and I'm going to write them this way. Do you guys remember what RBCs were?
White blood cells.
Oh, good. This is white blood cells. Very good, because RBCs were red blood cells. These are white blood cells. There are some white blood cells that are non-specific. My personal favorite are macrophages. And macro means big, and phage means eat. So guess what macrophage means? Big eater. And if I said Pac-Man to you, would you get a picture in your mind? Pac-Man, yeah. That's what macrophages do. They eat the bad guy. So if this is the little bad guy, okay, the macrophage comes over here and he eats him. Yay! And so there are other white blood cells, but these guys are my favorites, okay? And they eat the bad guys. That's cool. There's also something our body does called inflammation. What do you think of when you hear inflammation?
Swelling.
Good. Lydia's over there like this going, ow. Yeah. Swelling, right? If you had a cut and it got inflamed, it looked real red and it would get swollen. Inflammation is actually something that God set up to help us, because what it does, the reason it looks red, it'll feel hot to the touch, is because the blood vessels are opened up so that more of these guys can come help fight the battle. Just like if you get a fever is actually systemic inflammation of the whole body, because when your body heats up, not too hot, but enough, when your body heats up, it actually speeds up all of your defenses that want to fight the bad guy, and it's trying to cook the bad guy so that he breaks down. Okay, so they're actually set up to help us, and we'll come back to fevers another time because they're important and we'll talk about them. That's inflammation. So inflammation in itself is not a bad thing. The problem is that if you don't take care of it, it can become a problem, okay? Because your body's trying to fight, so you want to help your body to fight. Now, there's one other here I want to say up here. I'm going to put it, and it's called natural. You'll love this name, and I did not come up with this. Natural killer cells. And that's not just from our studying with the guys. They're actually called natural killer cells. Natural killer cells specifically seek out cells that have cancer in them or viruses in them. On the outside of our cells, say here's a cell, our cells have little flags that are called antigens, and I'm just going to put AG for antigen. And an antigen is just a molecule that sits on the outside of the cell, and our cells say, like my cell's antigens say Catie Frates. So when my immune system is looking at things that come into the body, if they see something that has I want to call it a flag, because we're doing an army scenario. If we see a flag that's other than a Catie Frates flag, my immune system should mount an attack and try to get rid of the bad guys. Does that make sense? If you have an autoimmune disease like rheumatoid arthritis or like lupus, one of these autoimmune diseases, what that means is your own immune system is fighting itself. It no longer recognizes your flags as you, and it's starting to attack itself. That's not good. Okay? Those are autoimmune diseases. So these are antigens, and that's what your immune system looks for. These are the flags. Natural killer cells will look at the flags of a cell with a virus in it, and the flag will be like, let's say normally the flag looks like this. If it has a virus, the flag may look different. It may look like it's at half-mast. Or if it has a tumor cell started, it may look down here. It will look differently. And when it does, it's the natural killer cell's responsibility to take out that cell. Kill that cell before the virus can spread or before the cancer can spread. That's the idea. Okay? So that's natural killer cells. And they're, once again, not specific. Once your body has a foreign invader in it, and it's gotten past all these other things, got past your tears, got past your skin, got past the acid in your stomach, got past the macrophages, really a bad guy, got past the natural killer cells. Now we have white blood cells that are called lymphocytes. And the lymphocytes, there's two different types of lymphocytes. And your book actually talked about lymph, and from the reading I've done, Remember the liquid part of your blood was the plasma? And when the plasma, the liquid part of your blood, leaves the blood vessels and migrates into the tissues, it is then called lymph. It's kind of like, where is it? That's what it'll be named. So it's the liquid portion of your blood without the blood vessels, like the blood cells. That's what the lymph is. And the lymph will hold lymphocytes. There's two basic types of lymphocytes. There's B cells and there's T cells. No kidding, that's what they're called, even at college. The reason is all lymphocytes, like all your other blood vessels, are made in your, does anybody remember where they're made? Bone marrow, very good. Somebody said bone, your bone marrow. The ones that stay in your bone marrow to develop are called B cells. The ones that migrate to your thymus gland are T cells. That's where they get that. You don't have to know that. I just want you to know that that's where that comes from. The reason people get vaccines is because they want to have antibodies against whatever those vaccines are for, whatever diseases those vaccines are for. What antibodies are, B cells, when they see the bad guy, they make arrows that are specific to that bad guy. That's the job of a B cell. And those arrows, so here's a B cell, it makes antibodies. And the antibodies, what they look like instead of a regular arrow is it's a Y-shaped molecule like this. This part is called the constant region because it's not different. This part up here is very specific. Let's say it made an antibody against Catie Frates. Then if I shot that antibody at Erin, it would bounce off of her. But if I shot it at me, it would stick to me. They are very, very specific. And this is the end of the antibody that's specific. So let's say this good guy shot it at a bad guy. Now we're going to make this a bad guy. Okay? Then the antibodies would stick to the bad guy like this. And they would actually stick to one another too once they started to stick to the bad guy. That's how the antibodies work. And the B cells make those. Now, it was probably in the reading you did that they make 2,000 antibodies per second once they get geared up. Yes, Erin?
Is that like why you take antibiotics?
We do have antibiotics, and antibiotics will kill certain bacteria, but not all bacteria. And that's why we have different types of antibiotics. So we've got the B cells making these, and they're very specific. While certain B cells are making 2,000 of these arrows, now you can see why we had archers, right? Ping! Okay? Making the arrows, there are also what are called memory B cells. And the memory B cells are going back over here in the body and they're saying, okay, we're going to build an arsenal, and the next time this bad guy shows up, we've got his number. We're going to pull out those antibodies and twang him, and that's it. And so that's why they do vaccinations. That is the premise behind vaccinations, is the idea that if your body sees a low grade or a version that can't hurt you, and it makes a response, then the next time you see the really bad version, your body should be ready to attack it so you don't get the disease. That's the idea. So these are very specific. You're going to be looking at this in your lab today. Once these antibodies stick to the bad guy, they will cause either the ninjas, which are called the complement system, 20 little ninjas, to come in and cut the bad guy into little pieces, and then the macrophage will come along and eat it. Seriously. Or it'll make them what's called agglutinate. And what agglutination means is it clumps up. So this will get like a bunch of them will clump up, and then the body will come in and remove them. And we see that frequently as pus. That's where the bad guys have died and the good guys have come in and they're trying to take out the bad guys, and then the body flushes it out, all those dead things, as pus. T cells, like I said, these guys don't shoot the antibodies. They have them attached to the cell. The cell itself has a specific part that looks for the bad guy, but the cell itself, and they're called, you ready for this? I did not come up with this. Killer T cells. We already had the natural killer cells. These are killer T cells. There are helper T cells, and there are suppressor T cells. The killer T cells go in, literally attach to the bad guy, and then cut them up. Okay? The helper T cells tell everybody else, make antibodies, get it going, let's do it, dudes. We got to get it going and start the fight. And then the suppressor T cells say, okay, the guy's dead. Back it down, dudes. Let's bring it back down. You don't need to be sick anymore. And so that's very, very important. And there are also memory T cells so that your body can respond later. On human red blood cells, there are 3 possible flags, antigens. There is the A flag, there is the B flag, and there is the rhesus factor flag. RH, rhesus factor flag. Human beings can have no flags, and if they have no antigens, they are called an O negative. That's their blood type. If they had one flag, they would be an O positive. That would be their blood type. The plus or minus just tells you if this one's here. If this would have the A plus it had the plus sign, this would be an A positive blood type. Do you see how this is working? This would be a B minus blood type. If you add the rhesus factor, it would be a B positive blood type. And once again, this would be an O positive because there's no A or B. And somebody could have all three flags, couldn't they? They could be AB positive. Or they could just have the A and B and no rhesus, and then they'd be AB negative. Does everybody see how that works? And this is a genetic trait that's passed from your parents. And it's that 85% of the population's Rh positive. Most people are Rh positive, but there are people, my mother's Rh negative. Okay, my mother's father was O negative. He could give blood to anybody because this is how this works. Let's say I'm an A positive. My body is used to the A flag and the plus flag. If you put a B flag in me, my body will go through anaphylactic shock and die probably because it's going to be so busy trying to fight that throughout my entire bloodstream. And this is why it's so important when they give you blood that they blood type you first. Let's say this blood was given to this person. They would still probably have anaphylactic shock, which will kill you because their body is fighting the A flag because all through their body because it doesn't belong there. But let's say you were an AB positive. You can take blood from anybody. Your body's seen A, it's seen B, it's seen plus. Give me blood from anybody, no problem, right? My grandfather had no flags on his blood. He was an O negative. He could give blood to anybody because his blood didn't have any flags on it, and therefore it didn't cause an anaphylactic reaction in anybody